morning, dear developers. It's We Are Developers Live Week number 3, and we are on Thursday. And it's early for some of you, late for others, but you all have one thing in common: you are here for the workshop with Stein. But before we go in this direction, I want to point something out. This whole event is not possible without our community, and part of our community are also our partners. And this week's main partner is the Vienna Business Agency and the City of Vienna. And we also have a sponsor for this day, and it's IBM. By the way, if you work for IBM and you have one of those cool t-shirts with the I and the B, and yeah, I would kill for one of those. Not really, yeah. But I would like to have one. So, what is going on this day? Well, everything works as expected, but remember, Slido is on this side. If you are watching on YouTube or Facebook, you will see that there is no Slido on that side, because you have to go to wearedevelopers.com/live-week, and there you will find Slido. We can use it for Q&A. You can give feedback to the speaker after the talk. And yeah, that's more or less it. So there is only one thing left for me to say, and that's this event is subject to the code of conduct. And the code of conduct basically says, please treat each other with respect. And the long version goes something like this. So, hello Stein, how are you this morning?
Hey Stefan, I'm doing very well, thank you. I'm excited to be here today and I have the opportunity to speak to so many developers. So great to be here.
That's good. So everybody in front of the screens, please put down your coffee cups, because now you have to be very focused. And I will now turn off my camera and microphone, and we'll be back for the Q&A.
All right, thank you Stefan, and a very welcome from my side today. We're going to have some fun during this workshop, and we're going to more specifically talk about Kubernetes. We're going to talk through 5 steps on how to run and scale Kubernetes with confidence. A quick word first before we jump into all of that about myself. So my name is Stijn Polvliet. I am a Kubernetes evangelist and director of our developer ecosystem at New Relic. Originally from Belgium, currently living in the sunny Barcelona. And I'm really passionate about everything related to Kubernetes and Docker, the microservices, and the cloud native ecosystem. I was the founder and CEO of a startup called CoScale. And at CoScale, we were offering a monitoring solution specifically for Kubernetes environments. CoScale was acquired by New Relic about 2 years ago. So it's been a very exciting journey for myself personally, and I'm really happy here to talk to you today about, what do we really need to think about if we are moving our Kubernetes environments into our production environments, and if we want to scale with confidence. So that's what we're going to do today. We're going to talk about Kubernetes. I will be showing lots of demos, making it very hands-on. And I think we all understand some of the benefits that Kubernetes brings us. For example, if we think about the flexibility it brings us, we can easily deploy our applications and we can easily scale them out. For example, if we run a service in a deployment, we can, or in a replica set, we can easily say, okay, let's scale up the number of containers for this service. So this is cool. Kubernetes also allows us to use our underlying resources more efficiently because we can schedule multiple containers, multiple pods on our nodes. So this is all great, these benefits, but it can also be scary, right? Because if we are doing this auto-scaling behavior, what we are seeing is very dynamic behavior, lots of dependencies in our Kubernetes environments. It can be scary. So how do we make sure that we have confidence? Something else that can be scary is jumping out of an airplane. And I generally like to do scary things. So this is me jumping out of an airplane in Australia 2 years ago. But I don't want using kubectl or managing my Kubernetes cluster to be the scary thing in my day. So what are we going to do about this? How are we going to run our Kubernetes environment with confidence? That's really what we're going to talk about today. And what I would like to take you through is an observability model that we have built at New Relic. And this is based on kind of the years of experience working with customers that are running Kubernetes at scale. So we try to summarize, okay, what are really the important steps you need to think about when you're building your Kubernetes environment and trying to run it with confidence. So we're going to be talking through each of these layers in detail. But at a high level, what we're going to start with is the bottom layer here. So the first layer, where we're going to look at, okay, as a Kubernetes operator, how do I get a sense of the overall health and capacity of my cluster? And what I will do in each of these layers, I will also share some best practices. So some generic best practices on things you should be thinking about or using to build or kind of manage your Kubernetes environment. In the next layer, we're going to be talking about the dynamic behavior in our clusters. And more importantly, how do we understand what the impact is of this dynamic behavior on the performance of our cluster, on the availability of our cluster? Next, we're going to look at log messages, log files, because a lot of the technologies we're using today or applications we're building, they're generating log messages. So we want to be able to use the information inside of these log files to understand what's happening in our environment. Next, we're going to look at how the microservices in our environment are communicating with each other. And think about the following. We're breaking down our traditional monolithic applications into smaller microservices. So the communication between those microservices is becoming more important. There is typically a lot more communication happening between the different services than in our traditional environments. So we're going to look at techniques to understand those communication paths. And then finally, what we're really trying to achieve is complete service observability. So understanding all the different aspects related to the services we're deploying in our environment. And some of you might recognize the Prometheus icon here. So we're also going to look at how can we leverage the great open source work and that has been kind of delivered by the Prometheus community. Okay, so before we jump into details for each layer, I would like to start with a very quick demo to give you a sense of, what are we trying to achieve here today? What do we really would like to get for observability in our environment? So I'm switching to my my other browser window here, and I'm logged into New Relic 1. So New Relic 1 is an observability platform. And what we're going to do during this first demo is we're going to focus on what we call our Kubernetes Cluster Explorer. So what you see here on my screen is our Cluster Explorer. And the Cluster Explorer allows me to understand what's happening in my Kubernetes environment. And what you see here is one cluster. Each slice of this pie here represents a node in my cluster. If I hover over it, I can get like a summary of the resource consumption of these nodes, for example. If I move towards the center of this circle, I can see the pods. So these are the hexagons on our Cluster Explorer here, the pods that are running on these nodes. So it allows me to understand where my containers, my pods are running. But of course, my attention here is drawn to the pods that are marked in a color here. So these pods are indicating that something is happening. There potentially is a problem. If I look at the very center of the Cluster Explorer, I can see the pods that are in the pending state. So it means that Kubernetes was not able to schedule these pods onto our cluster. But of course, the question is, yeah, why? What's happening? Why are these pods here marked in yellow or red? So what we can do with the Cluster Explorer is we can drill down on any of these pods here to get more information. And so what you can see, for example, in this case, if I look at one of the pending pods, is that, okay, the status is pending. They're not scheduled onto the cluster, but why? And what we can see here is that apparently we provided an invalid image name. So Kubernetes is unable to retrieve the image from our container registry, so it can't schedule it to the cluster. So by bringing in the context of what's happening, we can understand why this pod is in the pending state. Let's have a look at another example, and I'll talk in more detail about some of these examples later, but here's another example of a pod that is marked in red. So something is going wrong. It is scheduled onto the cluster, so it is running. What we can immediately see here is this pod is part of our coordination namespace. It's part of the order confirmation deployment. So we get more information about kind of the details of this pod and the containers running inside. Now, at the same time, what we can see there is an issue. So this pod seems to be in a crash loop backup state. So it means that the pod is continuously being restarted by Kubernetes. So there is an issue here. Something is happening. We can see it's in the backup state. But again, the question is then, yeah, but why is it in it? Why is it being restarted? What's happening? Well, with one click of the button, I can click here on See Logs, and this will take me to a window that shows me the relevant log messages for the specific pod I clicked on. So I don't have to switch to my command line and use kubectl get logs. I don't have to switch to another tool. Everything is surfaced here right within the context of the Kubernetes Cluster Explorer in the New Relic 1. So what we can see here in this case is it looks like there's a process running. In this case, it's a stress process, and it is causing our containers to crash, which is causing the restart. So by pulling in those log messages, I can very quickly get more details and context to what's happening with my environment. Now, if your environment is larger, you have many pods, many different deployments, many different namespaces, this can become very complex, of course. So what we can do here on the top of our Kubernetes Cluster Explorer is we can search and filter. So for example, what I could do is I can say, okay, I'm interested in a specific deployment or in a specific namespace. I type in a name and I see the options on which I can filter. So for example, in this case, I might be interested to understand, okay, show me everything related to my order status deployment. And then I can see, okay, I currently have a number of pods running for that specific deployment. So this was a first very quick demo to show you how we're bringing in context into the Cluster Explorer. And we'll dive a lot deeper during this session. But I wanted to give you a feel of what we're going to be using today. So let's move on. And again, let's think about the observability model that we have in the back of our mind. So the first layer is really about the overall Kubernetes health. So how can we get information about the various objects that are running in our Kubernetes environment? It begins with using a service called kubestate-metrics. And kubestate-metrics is an open source project that basically exposes health information about all the objects in our environment. So what we want to be doing is we want to leverage that service to capture information about our Kubernetes pods, deployments, etc. The next thing, of course, we want to do is we want to use a observability agent, such as New Relic, to hook into kubestate-metrics and start fetching that data and surfacing it in our dashboards, and in the case of New Relic, in our Kubernetes Cluster Explorer. Now, typically, what you have to do if you want to set up a observability platform is you need a license key or a password. As a best practice, use Kubernetes secrets. It is really not done anymore to put plain text passwords, for example, in your YAML files. So use a Kubernetes secret to store your passwords safely in your Kubernetes environment. That's the first generic best practice that we should all be applying. Now let's dive a little bit deeper. How can we understand the resource consumption in our cluster? And this is another generic best practice that I recommend to all of you if you're building out your Kubernetes environment is think about using resource requests and resource limits. Because as an operator, you want to have control over the resources that are being consumed in your cluster. And of course, we want to motivate other teams, development teams, DevOps teams to use our Kubernetes environments. But at the same time, we want to have control over the capacity in our cluster. So resource requests and resource limits allow you to have control over the capacity in your clusters. And there are two important concepts. The first is the resource request, which basically tells Kubernetes at the time of scheduling an object like a pod on your cluster, how many resources are we requesting? How much CPU cores? How much memory usage do we want initially to start or to deploy the pod onto the cluster? The other important aspect is resource limit. And this allows you to tell Kubernetes, okay, I don't want this pod to consume more than a specific amount of CPU cores or more than a specific amount of memory. So this allows you to have control over the resource consumption. Now, what's important to know is what happens if you reach that limit. So if you reach the CPU limit, this is somewhat okay. Kubernetes will throttle the execution of the pod. So, nothing kind of really bad will happen. Although it is important to keep track of this because your application will be slowed down. However, if your pod reaches the memory limits, this is bad because Kubernetes will kill it and restart it. So we want to make sure we keep track of those resource requests, resource limits, and the actual resource consumption. So let me go back to New Relic 1, and let's have a look at our Cluster Explorer again. So first of all, let me start again from our search and filtering bar here. So let's take a deployment as an example again. And in this case, as an operator, I might be interested, okay, how many pods do we currently have running for a specific deployment? So what I could do again is use the filter bar and type, for example, in this case, order status, zoom into this specific deployment, and then I can see, okay, we currently have 6 pods running as part of this deployment. It also allows me to understand on which nodes are these pods running. So if I hover over it, I get a little bit of information. I can see what is the specific pod name, on what specific node is it running. But if I want to get more details about resource consumption on this node, I can click on the node here. Clicking on the see host details allows me to understand, what is the overall resource consumption of this node related to CPU load, memory usage, storage, network, the amount of processes that are running, etc. But the next thing I'm interested in, of course, is how many resources is my pod consuming? So let's click again on one of these pods here. And on the right-hand side, we get more details again about what's happening with our pod. This is a live demo, so it looks like okay. It took a second, but in this case, what we can see right now on the right-hand side again is the pod is running as part of the interactions namespace and some other details. What I can also see here is how many resources is this specific pod consuming. And what we see here is the blue line represents the actual resource consumption. So for example, the amount of CPU cores that is being consumed or the amount of memory that is being consumed. While the yellow line represents the amount of resources we requested, and the red line represents our limit. So these are the important, again, metrics to keep an eye on, because if your blue memory line reaches the red line, the limit, it will be killed and restarted by Kubernetes. So behind the scenes, New Relic will automatically create alerts. So if your pod reaches the memory limit, it will automatically send out an alert, and you can act on it accordingly. Another interesting use case here, if we think about capacity planning, is we can use this information to see if we are over or under provisioning our cluster. So for example, in this case, I can see that the CPU usage of my pod is a lot lower than what we initially requested. Now, Kubernetes is taking into account this request when we're scheduling pods onto our cluster. So if we're over provisioning, if we're asking too many resources, it will be more difficult for Kubernetes to schedule the pods into our cluster. So we want to keep an eye on the actual resource usage versus the amount we requested and the limit, as I mentioned earlier. I will come back later to what we see here on the bottom of the screen. This is related to the application performance, but in this kind of first step, we're focusing on the resource consumption. All right, cool. So to summarize, think about using resource requests and resource limits to control capacity in your cluster. Another best practice I want to share is think about how we're building our microservices and the idea. We want to be agile. We want to have these small microservices that are easy to scale out, easy to move around, etc. Now, if you're building a container image, keep the size of your container images in mind. And why is that important? Well, because it improves the time to build, but also it improves the time to pull images from your registry. Another important aspect is security. And let me explain this in a bit more detail. So let's say you want to build a Node.js application. What you could do is you could start from a generic Node.js image. And typically these generic Node.js Linux images, they contain an entire Linux distribution. So for example, it might be based on an Ubuntu Linux distribution. So it means it has all the libraries, all the tools, everything you would find in a normal Linux distribution. But do you need all of these tools to run your Node.js application? You don't. So think about using smaller, purposely built images for the application. Example of this is Alpine. So Alpine is a flavor of images distribution, Linux distribution, that focuses on very specific application technologies. So for example, there is an Alpine version for Node.js, which is a lot smaller and only contains like the necessary tools you need to run your Node.js application in your Kubernetes environments. And the difference is huge, right? So if we compare the footprint of a base Linux image, it's about 700 megabytes versus an Alpine image is only 65 or 70 megabytes. Now, why is this important from a security perspective? Your footprint for potential security attacks or vulnerabilities is a lot smaller. So that's an additional benefit next to the kind of performance and improved time to build. So that's an important aspect. Okay, let's move on. So we talked about overall health and capacity in our clusters. And we're now going to talk about the dynamic cluster behavior. And as I mentioned earlier, many things are happening in our Kubernetes environment. We might have auto-scaling, we might have deployments that are failing, we might have resource contention, pods being evicted, many things are happening. So we want to track of that dynamic behavior. And typically what you would do is you would use your command line and use maybe something like kubectl get events. Now, the problem with this is we want to get more context. We want to put this in context of all of the other information we're capturing. So let's have a look in a minute how we can do that with New Relic. But as a generic best practice, what I would like to share with you is think about health checks. Health checks are a way to determine if the behavior of your service is as you would expect. And there are two types of important health checks. There are readiness probes and there are liveness probes. A readiness probe basically tells Kubernetes when your pod is ready to accept traffic. A liveness probe tells Kubernetes, is your pod still alive? Is it still able to process requests coming into your pod or your service? So let's go back to our Kubernetes Cluster Explorer and let's have a look at those events. So let me close this one, zoom out again. And first of all, we might have a lot of things happening in our environment. So if I look here at on the left menu, I can see that there is this events tab here. So what I can do is I can click here and this will show me a stream of events. So everything that's happening in my environment. And I can see, as we saw earlier, we have an event that was triggered because Kubernetes was unable to schedule a pod on the cluster because we provided an invalid image name, as we can see here. But there are other things happening. For example, we have that backoff event, which is causing our pod to be restarted. So those events, they give context to what's happening in my environment. Now, I have another test environment here where I would like to zoom into, let's have a quick look into a specific deployment. It's called our front-end deployment. And in this case, we can also see that this front-end deployment is marked in red. So something is going on. If I click on it, I can immediately see what's happening. Again, we're in a backoff state. So something is happening. It looks like the container has been, the pod has been restarted over 4,000 times. And again, the question is, why is it restarted? Now, in this case, it is restarted because it is in an unhealthy state. So as we can see here, the liveness probe failed. So we have a liveness probe that is periodically checking if our pod is able to accept traffic. And it looks like it is failing often. So we can use that information to see, why is it in a backoff state? And then, of course, the next step for us is, why is the liveness probe failing? So we could use the log files to dig deeper, but I'll come back to that in just a minute. All right, so we talked about, events, the importance of health checks. So really think about using these health checks to basically give more information to your Kubernetes scheduler about the health of your pods, and then use an observability platform such as New Relic to understand when and why your probes are failing. Okay, let's move on. So I already kind of spoke a little bit about log messages, and it's really important because many of our services and technologies are generating log messages, creating a log file in some form whatsoever. So we want to capture that data. We want to correlate it with the other information we're capturing. What I would recommend is to use FluentBit in a Kubernetes environment. FluentBit is lightweight. It was specifically built for microservice Kubernetes environments. Now, the cool thing is that you can use the New Relic FluentBit output plugin, which basically means that you can rely on the open source framework FluentBit, and you can use the New Relic plugin to forward the log files, the log messages to the New Relic platform. So you don't have to worry about storing those log messages, failover, scalability of your storage. on the long term, New Relic can take care of that for you. So let's go back to our environment. And so if I zoom into our, let's take our order confirmation deployment now. If I zoom into this one, I could see earlier that something was happening. So I can, again, with one click of the button, I can pull up the log files to give me more context. And this allows me to, focus on the problem I have at hand. Now, what you see here in this interface is, so this is our logging kind of search interface, and we're automatically searching for a pod with a specific pod name. But what I could do is I could also type in something else. So I could, for example, just type in the error keyword. And what will happen now is we will only show log messages that have the error keyword in the message itself. Now, as you saw, this interface works really fast. So the way New Relic is architected, we store all of this log information in what's called the New Relic database. Now, behind the scenes for searching, we don't rely on indexes. So this is the way the New Relic database was architected. And it means that for all of the attributes, for all of the keywords you search on, you get this kind of really fast experience. So that's really awesome to use. Now, what you can also do with our kind of logging experiences, you can set alerts. So, for example, if you see the occurrence of a specific log message, you could trigger an alert, etc. All right, cool. So let's move on, and I'll show one other log message in just a minute. But I want to talk about the communication between our microservices. So we have many microservices that are communicating within our Kubernetes environment, but we might also be calling out to other third-party services, to other third-party vendors that we're using, APIs we're calling. So we want to understand how much time we're spending in each of these components. And the way to capture that type of information is by using a concept called distributed tracing. So distributed tracing allows you to understand that communication flow between all your different microservices. And there are two important concepts here. The first is the concept of a trace, and the trace represents the entire flow throughout your environment. So imagine that you have a user coming into your environment, making a request to your system, or doing an action on your website or your mobile app. This request will propagate through your entire system. That's a distributed trace. Now, each individual component, so the execution, for example, on a specific container, this is called a span. And so this collection of spans is basically what builds your entire trace. So this is some terminology we will be using to look at this communication in our stack. Now, if you want to use distributed tracing, you can use the New Relic APM agent for this. So if you use the APM agent inside your pod, you get automatic distributed tracing out of the box. So what we will do is we will instrument the HTTP headers. We will basically add like a unique identifier to the HTTP header. Now, this unique identifier allows us to stitch together all of the communication across your stack, and it allows you to understand how much time you're spending, where there are potential bottlenecks. So we'll have a look at an example in just a minute. We also support open standards. So there are very popular open standards these days, like OpenTelemetry or Open Tracing, which can be used in combination with the New Relic platform. So let's go back to our environment. Let's zoom in on one of our deployments again. I'm going to take our order status deployment again here. And as we saw earlier, when I click on one of these pods here, I get resource information, but I also get a summary of application performance. So this allows me to understand at a high level how the application servers inside this pod is behaving. So what is the error rate? what is the average transaction time. So transaction time is like the latency or the response time. So how fast are we responding to the requests that are coming in? And what is the throughput? So how many requests per second are we handling? So this gives me an overview. But again, if something happens, I want to be able to dive deeper. So with one click of the button here, I can pull up the relevant traces for the application service running in this pod. So what this shows me now is an overview of all of the traces that were captured. So on the top of our window here, we see all of these dots. So each dot represents an individual distributed trace. On the bottom here, we can see a table view. So this is very similar. These are the same individual traces that were captured, which can then be sorted, for example, on durations, on the amount of entities, amount of services involved, or if there were any errors. Of course, what we want to do is we want to dive deeper. We want to understand the details of those individual distributed traces. So let's click on one of them here. And what this will show me now is a waterfall model. So it will show me how much time we're spending in each of the different services that are involved in this specific trace. So at the top here, I can see that 14 entities were involved in this trace. So an entity, in this case, we have 14 services. It could also be a database. It could be a queuing system. Those are also kind of types of entities that are kind of part of this, or could be part of a distributed trace. So in this case, we have 14 services. What we can see is that it starts with our order processing service, which is then making a request to order composer, which is making requests to order status, packing room, inventory, etc. So we can really understand how the communication is flowing through our environment. And we can also see how much time we're spending in each of these components. Now, if I want to zoom into a specific span, so remember, each of these individual components are called spans, I can get more details for these spans. So for example, if I click here, I can see the green line here, which is the span event. So that specific execution path, I can see, okay, how does the response time compare to other distributed traces that we captured? What was the throughput at this moment in time, etc. Now, if I see a span that has a interesting behavior or something I want to look at deeper, I can click on the attributes tab here, and it will show me on what very specific container ID it was running. So this allows me to identify if what specific container, in what specific cluster, deployment, any of the Kubernetes kind of metadata is all available here to have a look at. Right. Cool. So we can look at these spans to understand kind of the behavior in more detail. What I could also look at is what we call the in-process spans. So remember, we're looking at the communication between our different microservices, which is what we see here in the waterfall model. Now, what we can also do is we can also look inside a specific container, inside the application running there. So that's what the in-process tracing is really about. It allows us to understand, okay, in what functions of our application code are we spending time? And so, for example, in this case, we can see the entire call stack, and we can see that we're spending most of our time in this post function. So this is very detailed information that you can use to debug and troubleshoot your applications. All right, there's more. What if I wanted to stitch together all of the log messages that are being created in those 14 different services, so those 14 different entities across my environment? Well, with one click of the button here, I can pull up the log messages for this specific distributed trace. So let's have a look. So it shows me, in this case, we're looking at an e-commerce application. So we have a purchase order coming in, which has a specific ID, a specific number in this case. And what we can see is how this purchase order is propagating through our entire system. So we are initially arriving at a service that is apparently doing something around our shipment, packing, bubble wrapping, etc. So we're stitching together all of these distributed log messages and showing it here in our interface. So it really allows you to track those traces and those requests as they propagate through your system. Very, very powerful. Okay, let's close this one. Now, what New Relic will automatically do is we will look at these traces and we will perform some automatic anomaly detection on this. So if we see a span that is suddenly taking longer than expected, we will show you. So for example, here in this case, we will show you, hey, this specific span, it looks like it's almost twice as slow as normal. And then you can jump to that span and analyze it in more detail, as I showed earlier, by looking at the attributes and the span details. So this is where the Relic is really helping you to understand kind of in the huge amount of data that you're collecting when things are potentially going wrong. Okay, cool. So this was really about distributed tracing, trying to understand the communications between the different services we have. So let's talk about the final layer in our observability model, which is really about getting complete service observability. And what I want to recognize first is that the community, the Prometheus community in particular, has done great work. You know, many of the technologies we use, many of the services we deploy, they expose information, metrics in the Prometheus format. So what we want to be able to use that information and connect it with all of the other data we're capturing with kind of via kubestate metrics and with the New Relic agents. So there are two ways in the New Relic platform to capture Prometheus information. If you are familiar with Prometheus, if you have a Prometheus server running, you might like the auto discovery mechanisms, the configuration capabilities. You've probably put some effort in this. You might want to reuse that. Well, that's the first option here. So what you can do is you can keep using the configuration and your auto discovery mechanisms, but you can set what is called a remote write endpoint. And what this allows you to do is it allows Prometheus to forward all of the data to the New Relic platform. So we call this ingestion pipeline, we call this our telemetry data platform. So what you can do is you can point your existing Prometheus server with remote write to our endpoints, and then all of the data will be forwarded to New Relic. Now, the benefit of this is you don't have to care about long-term storage. You don't have to worry about scalability, the performance of your environment, failover, maintenance. We will take care of the long-term storage. So that's option one. The second option is if you don't have a Prometheus server running, or you don't want to keep your Prometheus server and the configuration locally, you can use our New Relic Prometheus Open Metrics integration. And what this integration will do is it will directly scrape the Prometheus endpoints in your cluster. And the way it works is this uses labels. So if you have a Prometheus scrape label, this can also be customized, we will automatically detect this label and start fetching that information from that specific endpoint. So it's easy, and that way kind of the New Relic agent takes care of getting the data and then forwarding it to the platform. So those are the two options. Now, once we have the data in the telemetry data platform, of course, we want to do something useful with it. We want to visualize the data. We want to analyze the data. So there are two options again here. The first option is to use New Relic 1, and I've shown the Cluster Explorer. In a minute, I will show some other dashboards. And what we can do there is we can use our dashboards to visualize that Prometheus data. I will show you it's easy to look at the data, add charts to a data, customize these dashboards, create your own dashboards. But if you're looking for more advanced capabilities, we support 2 query languages. And this is quite exciting. First of all, we have our New Relic query language, which is very similar to a SQL query language if you're familiar with SQL, but we also support PromQL. So if you're familiar with PromQL, you can write PromQL queries in our dashboards and reuse kind of the knowledge that you've built. So I'll show that in just a minute. But another option is to use Grafana. So a lot of organizations, a lot of customers, they are already using Grafana for dashboarding. A lot of the support teams or like level 1 teams are relying on Grafana dashboards for troubleshooting. So what we have recently introduced is a Grafana data source endpoint for New Relic. So what this means is that you can configure your existing dashboards to use New Relic as the data source. Typically, your existing dashboards might use PromQL. Our endpoint supports PromQL. So it means that you can keep using the dashboards that you already have available, and you can kind of rely on what you've built so far and just hook it up to our telemetry data platform. So let's have a look. So first of all, I wanted to show this dashboard. So, we looked at the Kubernetes Cluster Explorer, which is really a curated experience that we have built to bring together kind of important things related to your Kubernetes environment. Now, what you could also do is you could also build your custom dashboards. And this is an example of a custom dashboard. And a typical use case for a Kubernetes operator is to look at our DNS service. So typically core DNS in a Kubernetes environment. So what we're doing here is we're building a dashboard that shows me the relevant Prometheus metrics that we're capturing from our core DNS service, because core DNS is by default exposing this information over a Prometheus endpoint. So we're looking at those metrics. For example, here we can see how many requests, how many DNS requests is our DNS service handling. We can filter that by, or kind of break that down by queue type, by zone. We can look at the responses. We can look at the cache and the hit rate, etc. So those are my Prometheus metrics. But a lot more value, again, comes from combining this type of information with other information we have. So what I'm doing right here is I'm also showing the log messages from our core DNS service in the context of this dashboard. So it allows me to connect, troubleshoot faster, and understand what's happening. What we also have here on this dashboard are the relevant events. So what's happening in our environment, and then again tying that back to all of the other information we have in our Kubernetes environment. All right, so this is an example of like a custom dashboard with Prometheus metrics. In this case, also log messages and relevant events. Here's an example of a Grafana dashboard. So this is an existing Grafana dashboard of a Kubernetes environment, but as a data source here, we're using our telemetry New Relic platform. So this is really cool. You can rely on the queries you've built, the charts you've built. You can just rely on your existing Grafana dashboards and hook them up to our New Relic platform. As you can see here, we have many different kind of widgets related to network usage. We have CPU loads, container CPU usage. We have more related to memory usage, etc. So this data is all coming from the New Relic platform, but visualized in Grafana. And then so finally, what I wanted to show is the query builder. So here's an example of a PromQL query, and what you will see here is that you can switch to NERQL, so the New Relic query language as well. But I wanted to show you here that we support PromQL, and for example, in this case, we're looking at kind of the total amount of requests that our core DNS service is handling over time. So kind of this view is very similar to the metrics we saw here, as you see kind of in the trend line. So we can rely on NERQL, PromQL to visualize the data. You can use the query builder to do more complex interactions or build more complex visualizations. Or we also have a more, let me quickly show that to you here. We also have a kind of a wizard form that allows you to explore your metrics without having to learn a query language. So for example, here I can go to our data explorer, and then I can see, okay, I have here a bunch of core DNS metrics. What I could do is I could click on any of these metrics and kind of use this to start exploring my data. So the query language is, I would say, more for advanced use cases. There is also like a simple data explorer way to explore the data. Okay, cool. So, so we talked about Prometheus, the different ways of collecting Prometheus information, and then also the two ways of visualizing Prometheus information. I showed that we recently added native PromQL support in our in the Relic 1. So I'm going to skip this slide. And really what we're trying to achieve here is to get complete service observability. And we often talk about complete service observability in the context of MELT. So MELT for us means metrics, events, logs, and traces. So those are the four important data types we looked at during this session. And really think about how can we connect those four different data types with our end goal in mind. We want to be able to troubleshoot faster. We want to be able to run our Kubernetes environment at scale and with confidence. So we have more details about Prometheus. So if you want to learn how to, if you want to learn more about our Prometheus capabilities, you can go to our website, newrelic.com, click on About Resources, and you will find a webinar, specifically dedicated to running Prometheus at scale. The final thing I wanted to demo during this session is how do you get all of this up and running in your own environment? So yeah, let's skip ahead a little bit. So how do you get this in your own environment? We've made it easy to get the same visibility for your Kubernetes environments. So let me just show you how that works. The first thing you need to do is create your New Relic account. You could go to newrelic.com/signup. So let's have a look. Create your account. What's important to mention here is that we now have a free tier. So if you create your account, you get 100 gigabytes per month of free data ingest. You can use all of the capabilities I showed today for free. This is free forever, limited to 100 gigabytes of data per month. Now, once you've created your account and you log into your account, you will be taken to a home page. Now, on this home page, you will find a wizard. If you have an existing Relic account, you can also start this wizard by clicking on the Add More Data button here. And this basically guides you through a number of integrations for the Relic. So in this case, I'm interested in Kubernetes. So I can click on this Kubernetes button here, but we also have other capabilities here. So for example, if you want to learn more about how we support SNMP, Nagios, or if you want to know how we can monitor Cassandra, Apache, you will find wizards here on this kind of in this experience. Now, this isn't all of the integrations that the Relic support. This is like a selection of the most popular integrations that are surfaced here. So in this case, we're of course interested in Kubernetes. So let's zoom into Kubernetes. It takes me to, yeah, this is a message. You won't get this message, don't worry. It takes me through a wizard. The first thing I need to do is I need to select my account. I have multiple accounts, so that's why you see multiple here. I'm hiding my license key because I don't want to reveal that during this live stream. But basically, all you need to do is you need to give it a name. So for example, I want to name this workshop. And you can deploy it in the default namespace, or if you want to deploy it in another namespace, you can specify that here. And then you can select the options of the data kind of you want to capture. So if you want to get full visibility into everything I just showed today, enable all of it. What this will do is it will deploy kube state metrics, so the basic service for getting health information about your environment. It will deploy our Prometheus open metrics integration, so it will automatically start scraping those Prometheus endpoints in your cluster. It will capture Kubernetes events, log messages, everything you need to understand what's happening in your environment. And then there are two ways to install kind of these capabilities. You can download our manifest file, which is kind of one big YAML file that contains everything, or you can use help charts. I'm not going to click on it because I don't want to reveal my license key here, but I do want to show it very quickly. So you can select either of both options. Today, I see many customers using Helm charts. Helm charts is really a popular way. It's like a package manager for Kubernetes. It allows you to easily deploy all relevant resources for a specific kind of piece of software. So let me share my other screen very quickly. So just give me a second here. Yes. So here is my terminal window. So right now I have my local Kubernetes environment here. I've created this. Just gonna show it like this. So if you follow the wizard, it will show you a command like this. I've replaced my license key here with an environment variable. But what you see here is that we're setting your license key, the name of your cluster, the namespace to deploy it to, and then we're setting the additional options of deploying kube state metrics, enabling Prometheus, enabling the kube events, and enabling logging. And so the only thing you then need to do next is run this Helm command. So do a Helm install, and it will now be provisioned onto our cluster. We can check what's happening by doing let's do a get pods. And then in a couple of minutes, so as you can see, the containers are being created. The different components of the New Relic agents are automatically being kind of installed onto the cluster. Again, you can see kube state metrics. The New Relic infrastructure agent is actually the component that is responsible for communicating with kube state metrics and forwarding that data to New Relic. It also communicates with the local kubelet and some other things to get the relevant information. We have our logging component, which is responsible for forwarding the log files. We have the kube events. The metadata injection, this is a special one. This basically allows us to correlate the application performance with the pods. So what it does is it injects environment variables in the pods you have running in your environment, so we can correlate application performance with the containers. And then we finally have our Prometheus scraper running in your environment. Now, there is a good reason why we're deploying these components separately. Imagine the following scenario. Your Kubernetes environment is under high load, under stress. What Kubernetes will start doing is it will start killing pods. Now, of course, what we want to avoid is we don't want to lose visibility into our cluster. And one of the key areas to understand what's happening is this kube events collector. Now, this is very small. It has a really small footprint. So by decoupling this from the other agents, we're reducing the risk of Kubernetes evicting this pod from our cluster, which basically guarantees you that you will have that relevant information at all times, even if your cluster is under high load. So there is a good reason why we've kind of designed it this way. Okay, and then so in a minute, you should be able to see the data coming into your environment. So if I just click refresh here, I should be able to see the data coming in. So this takes a minute for the containers to be created, the agents to be started, to communicate with our kind of backend systems. And as you can see now, the data is flowing in. Okay. All right. So yeah, this is one more thing I do want to maybe also quickly show is, so the first was all related to our Kubernetes capabilities, including the Prometheus integration. if you want to configure your Prometheus environment with remote write, there is a kind of a separate guide for that. So again, go back to your homepage, click on Add More Data, and go through the Prometheus wizard. This Prometheus wizard, if you click on it, will show you the exact configuration parameter you need to put in your Prometheus config file. I'm not gonna click on it because I think it will show my license key. So it's easy, just follow those wizards to get the right integrations up and running. All right, to summarize, I encourage all of you to get started today, try it out. We have a free forever tier, as I mentioned, 100 gigabytes per month for free, and you can use all of the capabilities that I just showed today. We are at the hour now, so I am going to take some time right now to answer some questions. I believe all of you should have access to the tool for those questions, so happy to take some time now. Thank you.
So, thank you, Stijn. I think people are still processing all the information. Make sure to use Slido over there to post your questions. There is one anonymous said, "What were the melt again, please?" Melt again.
So, yeah, melt is like an at New Relic we like acronyms. So melt is an acronym. It stands for metrics, events, logs, and traces. And so the way to think about this, these are the important data types if you think about observability. And what's even more important is you need to connect all of those together. So looking at your metrics in one place, looking at your logs at another place is really hard for troubleshooting. So the idea of melt is really like, let's bring all of this together so you can troubleshoot faster and really get the necessary context from kind of when you're troubleshooting. So that's what melt is about.
And now the question everybody who uses Kubernetes has to answer at one point or the other. And it's not on the list. What do you wish you knew about Kubernetes before you started using it?
So one of the, I mean, maybe a bit controversial is it's obviously there's a big hype, right, around Kubernetes, and it's, if you look at kind of our ecosystem, and I'm a developer myself, I like to play with new technology. I like to learn new technology. So initially, it's like, oh, very excited. You know, you can do these really cool things. But it is really scary. It is really complex. Like, there are many different angles to Kubernetes. There is a lot of behavior that you need to kind of keep an eye on. And I think that's really why it's important to think about what are some of the best practices we should apply. And this is not related to New Relic necessarily. Think about what I mentioned today around the using container images, making sure that they're small enough. Think about using health checks. So there are all of these best practices that we can apply to have more confidence in what doing, and then still explore kind of these new areas and learn more, because it is really exciting technology.
That's true. So Candida says, thanks so much for your talk, Stijn. And
my pleasure.
There is another from Anonymous. Will this work with AWS EKS using Fargate workers?
Yeah. So we do have support for normal EKS with EC2 nodes and Fargate. In our documentation, you can actually find some more info about that. Just to make this clear, we support plain vanilla Kubernetes environments. We also support OpenShift. IBM is a sponsor today, so we do support OpenShift as well. We support all of the managed Kubernetes services. So, for example, EKS, as was in the question, but also AKS, so the Azure Kubernetes Service, the GKE, Google. So it really doesn't matter if it's like a plain vanilla or a derivative. It's all supported. So yeah.
Okay. So Peter says, thanks for the workshop. It was really good.
Thank you.
And another question, which is not on the list, but it's on my list. Is it true that Belgian people really love beer?
Yeah, that is really true. I am I'm quite passionate about the Belgian beers, and I'm originally from a very small town, only 3,000 people. And so the funny thing is, in Belgium, almost every town has their own beer. So I'm from a town called St. Paul's, and I'm very proud. I think we have the best beer in the world. So it's like everyone is proud of kind of brewing beer and proud of the culture. And that's something I do miss a little bit in when living in Spain and Barcelona. But yeah.
Yeah. And how did you get into computing?
So I did a PhD in computer science, and I was a part that was in Belgium here, and I was part of a group called Performance Lab. And in Performance Lab, we were looking at, okay, how can we analyze performance of applications running in data centers and in the cloud? And this is also basically where the idea of my startup, CoScale, started. So it got me excited about performance aspects, observability, monitoring, and I've been working in this space for over a decade now. So.
Okay, that's interesting. Anonymous, yeah, perfectly explained. Thank you so much. And then there's Craig Newton who says, thanks for answering the EKS answer. Much appreciated. We'll try to integrate it today.
Awesome.
Yeah. By the way, can people reach out to you on LinkedIn, Twitter?
Yeah, I didn't put my credentials in the slides.
I think there will only be one Stein.
Yes, there are many. So yeah, feel free to reach out, connect with me on LinkedIn. Yep, of course.
So, and Anonymous, again, awesome workshop. Another Anonymous, great workshop, thanks a lot. I think you answered a lot of questions, and you didn't drive too many answers which create new questions. That's a good one.
All right.
So, yeah. The question is, we still have time. We could do a philosophy round, or we say, thank you, Stein. By the way, how is the weather in Barcelona? Please make me envy you, because there is snow on the street and pavement in Vienna.
Sunny. You know, the thing and what I like about Spain is the sun comes out and it's immediately warm. Like I was used for many years to the gray days in Belgium, rainy days, and the difference in Spain is huge. It's always sunny, and yeah, it's a big difference.
And the working culture in Spain is different to what you are used from Belgium, or do you mostly work with US people?
Well, so New Relic has a big office in Barcelona. So there is an R&D develop. Actually, all of the Kubernetes capabilities are developed in Barcelona. So that might be good to know for the audience as well. Like if you have like feedback or like feature requests, it's all built out of Barcelona. So there are, I think right now there are 180 people, close to 200 in the Barcelona office, all engineers, all part of our product organization. We do work, of course, a lot with the United States. Our kind of headquarters or development headquarters are in Portland. So that is a 9-hour time difference, which is sometimes a little bit challenging. So we do typically kind of start a little bit later in the morning and then work a bit later in the evening to have more overlap with the teams in Portland and in the US. So, but I love the culture at the Relic. It's a very innovative company. So I'm really happy we joined, and kind of our team, our co-skill team. We were a small team. We joined the Barcelona folks, and I think we've all been enjoying it so far. So
that's very good to hear. Okay, so we gave people enough time to create more questions. They don't want, because they already know that they can contact you. So I say thank you, and a round of applause in the stream. And yeah, we will be back with the program at 1. Until then, we will drink coffee and look for lunch. Thank you, Stein. It was a pleasure seeing you. And
the pleasure was mine. Thank you.
Hope may the demo gods stay with you and everything be smooth when working with Kubernetes.
Yes. Okay.
So,
thank you, Stefan.
Thank you. And bye-bye.
See you later.
See you.
Bye-bye.
Bye.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
When magnetic fields move and electrons start flowing. When you feel that anything is possible. When the night can turn into day. Then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
VKW. Energie für Generationen.